Welcome to NASA Edge, an inside and outside look at all things NASA. We're joined today by Nicky Fox, who is NASA's Division Chief for Heliophysics. Nicky, before we get started, how are you and your family coping with the stay-at-home conditions that we're dealing with here at NASA?
Oh, we're doing very well. Thank you for asking. I think like everybody, we all have a very unique set of environmental challenges in our home environment right now. For me, it's two fairly young kids, both school age, who are dealing with learning from home for the first time. And on top of that, we decided this would be a great time to adopt a rescue pup. So it's a little chaotic here, but just like everyone else, we're kind of adjusting and dealing with the day-to-day challenges. But happy to say that life is still going on well in the Heliophysics division. So we've got lots of exciting things to tell you about today.
Yes, let's get into a couple of those missions. Most notably, Parker Solar Probe and Solar Orbiter. We've worked with you on both of those missions. Can you tell us a little bit about where you are with Parker Solar Probe and what kind of data you've been collecting?
Oh, I'd love to, yes. Well, I'm happy to report that Parker Solar Probe is still the coolest, hottest mission under the sun, and she is getting wonderful data. So yes, we have completed 4 flybys through the sun's corona, so that hazy atmosphere that we all enjoyed that spectacle of during the total solar eclipse back in 2017. And she is right in that region, so that hazy atmosphere is where she's flying through. She did 3 orbits, and then did a second flyby of the planet Venus. And so that 4th orbit, she actually was even closer to the sun than on those first couple. We saw incredible data, even on the very first cut through, things that we weren't expecting to see. We know that the solar wind is accelerated in the region close to the sun, but we really thought that on that first couple of orbits, since we weren't super close to the sun, we would really be seeing more of a sort of laminar flow, everything flowing away from the sun, bathing all the planets. As we went in, even on that first orbit, we saw these very strange signatures, and they turned out to be kind of like an S shape in the magnetic field. So essentially the magnetic field twisting back upon itself. Very interesting. Certainly can release a lot of energy. It's very much like twisting a large rubber hose. It's kind of hard to do. You have to put energy in to actually do that. And so as it relaxes and sort of springs back out, it lets out energy. And so we actually think this is a smoking gun for why the solar wind is actually heated and accelerated in that region close to the sun. After the second Venus flyby, we went even closer and we saw more of these signatures. They were sort of bigger in size as well as more frequent. So we're looking forward to following our 5th solar flyby. We will actually do another Venus flyby and we'll go even closer, and we expect to see even more exciting things as the mission continues.
I know that you and your team are used to seeing a series of firsts with these types of missions. Can you tell us about the reaction that your team had when they saw some of the data coming back, especially some of the stuff you weren't expecting?
Oh yes, you can imagine we're like, a kid in a candy store. Every time that another burst of data comes down to the ground, we're all excited to see it. And just to kind of give you an idea, the very first time we showed the data publicly, the PI, Stuart Bale, for the field suite actually showed this magnetic field data. And I kid you not, it is a black line plot just showing what turned out to be these fluctuations. But there were actually audible gasps from the audience, and it's a line plot. So, we still proudly wear our geek card and we get super excited by everything's coming down. But at first we thought it was, first of all, you worry that your instrument's working properly. But we knew that there was nothing wrong with the magnetic field instrument. And so at first we thought maybe we were sort of in like a transition region. So you've got field lines that are coming from one pole of the sun and then going into the other pole of the sun. And we thought, well, maybe we're kind of in that region, sort of between these two regimes of magnetic field. And all we're doing is sort of having that field kind of move up and down over the spacecraft. But when we looked and we added the data from the sweep instrument, so that's the sort of the plasma, it's telling us what the bulk solar wind is doing. When we added that data to the magnetic field data, we saw that actually it was exactly the same field line. We weren't sort of moving into another regime. We were staying in the same place, but but that field was doing these huge reversals. And so that was on the very first orbit. So we continue to get wonderful data, all kinds of new and exciting things coming out all the time.
Well, it's great to hear about Parker Solar Probe, but let's talk about Solar Orbiter. Are you receiving any data from the spacecraft?
So actually, yes, we are receiving some from Solar Orbiter. That mission, of course, launched in February from Kennedy. In fact, that was the last time I saw you guys down at the launch site. And they were able to continue to commission that spacecraft even in these very, very, very trying conditions. And so it's kind of a shout out to the whole Solar Orbiter team for the way that they have been able to adapt to this more virtual environment. No one, of course, was able to travel to ESA, to the control room, to really do the commissioning. And so they were able to set it up so that everyone has been able to commission their instruments from their home institutions. So we're very, very happy to report that all 10 instruments have now been on. They have all produced first light data. And some of the in situ measurements are very, very similar to those instruments on Parker Solar Probe. And so we're actually very excited and looking forward to the next perihelion pass of Parker, number 5. We actually hope that we'll have some Solar Orbiter data at the same time, to get this sort of multi-point messenger data from the inner heliosphere. So it's very, very exciting.
Well, I know over at Heliophysics you've had past missions, you have current missions that you're working with, and then you have future missions. One that I've just recently found out about is a mission called the Sun Radio Interferometer Space Experiment, or SUNRISE for short. Can you tell us a little bit about that mission and how it incorporates the use of CubeSats?
Yes, we're very, very excited about our new mission, SUNRISE. And it was also the first time that we have been able to select a mission totally virtually. So we did the authority to proceed meeting. Everybody logged in from their home offices, and we were able to hear the wonderful progress that the team had made in their initial study and ready to really go into implementing that mission. But it's exciting both from a science perspective and also from a technology perspective. This is really going to be 6 CubeSats that are acting almost as one large radio receiver dish in space. We're looking at very, very small scale features. We want to make some very, very, very accurate measurements. And so often when you want to make accurate measurements, you need a huge detector. But, we'd need a giant detector flying in space. And right now we don't have the technology to be able to launch and fly, a detector that's a couple of football fields across. But with 6 CubeSats, we can sort of position them, and then together they talk to one another, and they basically form like one large array. And so, just from a technology perspective, I think it's really cool. 6 CubeSats working together. So, multi-point measurement again with the 6 CubeSats. And then the science they're going to be listening to the radio signals, things that are associated with coronal mass ejections. We know there are radio signals, and if we can do a better job of picking those up, it actually will really help us be able to predict the events that are coming towards us, and really help us know when they'll arrive and just how geo-effective they'll be. So we're really, really excited about this addition to the inner heliosphere fleet. We also have Punch, which is another new mission that we selected last year, but they're really almost looking at the sun from the inside out. They're looking very, very close in at coronal mass ejections. They have an amazing coronagraph on that mission. 4 spacecraft there. One is a sort of a very focused camera, and then the other 3 together are making up a wide-angled camera. So again, multi-point technology, really, really, really creative ways of using small spacecraft to achieve really big science in space. So it's a great time to be a heliophysicist, as always.
Nicky, that is great. We got some really good updates on Parker Solar Probe, Solar Orbiter, SUNRISE, and Punch. Thank you very much for joining us today.
Thank you, Franklin. It's always a pleasure to talk to you.
You're watching NASA Edge, an inside and outside look at all things NASA.